I have access.
Good evening, everyone. This is Jim Pilcher, and this is the February Denver Area Access User Group meeting. Tonight, I'm going to continue my presentation from last month, and this is all about SQL Server for Microsoft Access developers. In a quick recap of what I did last month, I put up some demo databases. I talked about Access versus SQL Server backends. I talked about scripting versus designers. We got into the tables, foreign keys, things like that. The interesting field types that are of particular interest, I believe, to Access developers when you come to SQL Server, and those were the date, time, the row version, and bit fields, I think are very interesting. And we had a little bit of a discussion of triggers in SQL Server. And there is an equivalent, data macros and Access. So we talked about those a little bit. Then we got into talking about views, which are the SQL equivalent of Access queries, and talked about the various ins and outs of views. And then right toward the end of the presentation, I started talking about functions, scalar functions inside SQL Server. Tonight, we're going to take a look going on from there at table valued functions and stored procedures. Hopefully we'll get to talk about when you're in Access, when you use an Access query versus a SQL view. And if we have enough time, I want to show you some of the tools that I use as an everyday SQL developer and Access developer. I've got tools both on the SQL side and tools on the Access side that I use every single day, and I hope to show you those. One of them that will particularly interest you folks, I think, is there's a brand new find and replace available for Access. Rick Fisher's 25-year-old version is no longer updated. You can't buy it anymore. And a brand new one came out just last month, and I'm testing it out. So I hope to get to show that to you tonight. If I don't, we'll maybe show it briefly next month. So I want to get started here. I'm going to open the SQL Server Management Studio, affectionately known as SSMS. And what we're going to do is we're going to look up a function, and a table function, I should say. So I'm going to do, I know there's one in here that begins with FNTABLE, and down here we can see this function. Now, a table valued function does not return a single value like a scalar. As its name implies, when you invoke this function, it returns a table of a specified design. So let me go there. We'll open this in as an alter. And what this particular function does is, as it says up here, this one does not take any parameters, but this function returns a single column called workday, and it's a date field, and it returns a list of dates on a daily basis from about a year prior to now till the end, till the final date in a project in this database. And you have lots of projects in the database. And we need this for resourcing, for graphing, things like that. And because it's not a discrete thing, the table doesn't exist, we write a function, and every time we invoke it, we get the table. I'll show you in a moment how it's used, but right now I'm just going to kind of quickly go through the programming. So this is very much like a stored procedure, but you can include this in a view where you cannot include stored procedures in a view. So when you are returning a table from a table value function, you can declare variables, you can have embedded select statements to get information you need out of the database, do some calculations on stuff, and then down here is where the meat of it occurs. And I am running a loop here, and you'll notice I've declared a table called workdays. That is what this function returns. And down here, I'm inserting into workdays, and you can see a value, and I'm inserting a single value because, as you saw, we had a single column that this table defines. And I looped through it, and I had determined the range. I got current date and end date, things like that. And when it's all done, it returns that table. So now what I'm going to do is show you how this is used in a view. So let's see. Let's go down here to this one. First of all, I'm going to run it. And what happens here is you'll notice, well, I've got a top 1,000. I want to show you this thing returns 85,000 rows. And this view has a particular interesting thing in it I'll show you. So there we have 85,716 rows, but the workday is what that function returns. Everything else is returned by the rest of the view. So if we go into the view now, this view is interesting because not only does it use the function, and I need to find it there. But I'm also using common table expressions. I don't know if I talked about them last month, but they're inside a view that's essentially a shorthand and easy way of using subqueries. So I've got a number of subqueries in here, but you can see what I do is I have a select here, and I'm selecting a bunch of stuff. I won't go into what it does. And then I do a from the resource table, and then I do a cross join from my function. And you can see I'm using it in a from, just like a table. And cross join is, if you folks are familiar with the term in Access, that's a Cartesian product. So there is no link between resource and days in range. And that means that for every row in resource and every row in days in range, it'll create a combination of them. So if resource has 100 rows and days in range has 200 rows, the result set's going to have 20,000 rows. So that is how I've used it here. So what I've managed to do is now I have a table that has a whole bunch of rows in it that allows me to specify resources and utilization for the resources. That's a fancy name for employees. Utilization on a daily basis for the entire database, not just a single project, but for the entire database. So down here again, I use it down here, and I've got a third common table expression that uses the first two, and then finally I do a summary. So really this is the query I'm running, but with the various common table expressions, I'm able to reduce it down to several more manageable pieces. So I'm going to go back up to the top here, and I've already run it, but I'm going to highlight everything here and just run it from here. Just execute it. And you can see again that we've got the 85,000 rows, And it starts on 1/28/2019, which is roughly a year prior to now. I don't know what the exact number was in there. If I go to the end, somewhere in the database, there's a project that takes us all the way out to March 13th of 2028. So everyone shows their allocation on a day-by-day basis all the way out till 2028. And then we can use that for Power BI graphing. We can use it for queries, views, whatever we need in the database. So I'm going to open another one here. Here is an example of a table valued function that returns, it takes two parameters, and you can have as many parameters as you want to help you specify what you need, and returns a table of 3 columns. And the reason I wanted to show you this is this particular function uses what are called cursors, and cursors in SQL Server are kind of like when you open a record set in VBA and you loop through the record set in code. That's kind of what you're doing with cursors. We couldn't use result sets here like a select because all I had was a range, you know, like a begin year and an end year, and I didn't have the in-between ones. So what I had to do was generate a table that had an ID, a portfolio hierarchy name, and then one row for each year between begin and end year. And I ended up generating a table that I can then use for my Power BI charting. And so now I'm going to go and I'm going to show you let's see, it's not there, so I'll open Power BI, portfolio and budget goals. So the first thing I'll do is show you the results set. This is using the function, and this will make a little more clear. I was sending in 2 parameters and getting back 3 columns, and the 3 columns I'm getting back are these. The ID, the name of the hierarchy area, and a year. Now this is 2016 to 2021, and you'll notice we go from 2013 to 2023. I'm now going to open this and show you how I called this using parameters. So down here, I do my select, and right here, I use the table valued function as the primary table in my select, and it's accepting 2 parameters. And the 2 parameters are how many years prior to the beginning of the portfolio hierarchy do I need this, and how many years following it, or vice versa. So that allows me to specify a range that's a little bigger than the portfolio hierarchy so they can get an overall picture here. So it's a function, and then I join it to other tables and I get the results that we saw right here. And we got all the other stuff here. So table valued functions, I don't use them nearly as much as scalar functions, but you can see that with my table valued functions, we have 1, 2, 3, 4 in this database, and the scalar value functions, I've got about 30, 35 of them, but they can be very useful when you need them. All right, I'm going to close all these. Now we're going to talk about stored procedures. Stored procedures really kind of get you into heavy-duty SQL development. Any programming structure you can imagine is available inside of a stored procedure. Maybe not some of the more advanced object-oriented stuff, but anything SQL Server can do with programming with loops and what have you. A variable declarations, select statements, everything you can put in a stored procedure. A stored procedure typically returns a table or a value. I'm gonna and I will tie stored procedures into Access here in just a moment. Even when you're returning a result set, which this one does, this is what it returns. You can also return a value in addition to the result set that you can use to indicate success or failure or some other scalar value. It might be the number of rows returned. There are a lot of things you can do to return it. So this particular stored procedure is one that I use to generate a pseudo crosstab query. SQL Server, for you Access developers who like crosstab queries, and I'm one of them, doesn't have anything native built in to give you crosstab queries. So you're kind of left to your own to do it. And that's what I've done here. You know, with a crosstab query, you pivot it and you get a good example would be you want to show things by month, and what you end up with are the months going across and your other information going down in the rows. So you would have 12 columns and then however many rows. So what I did here is I'm trying to show dates for every task that might be in the database. So I generate a list of columns I'm going to need on the pivot by selecting those names from our task table and putting a comma between them. And then I've got 4 SQL statements because I'm pulling 4 different kinds of dates. And I generate, this is SQL where this is dynamic. I'm actually specifying the select and everything else inside of a text string. And I'm going to concatenate 4 text strings together through doing this. And to make them more readable, if I want to see it, I put a line feed in there after the unions. And each of the concatenated together, I put a union statement between them. And then at the end, I do a select into a temp table, again, using dynamic SQL. And then inside the parentheses, my whole union is essentially a subquery, or actually a derived table. And then I execute that, and that actually selects everything I've done up above into this temp table. Then to return this to the user, and we'll get to that in just a moment, I then do the select from the temp table. And something I found was pretty cool is I can do my own cleanup, because once I've done the select, I can drop the temp table and the stored procedure still returns the result set. So what I'm going to do here is we are actually going to execute this in SQL Server in SSMS. Yeah, let's not do that. I'm going to show you how I would normally do it. So I'm going to do a rename, copy, I'm going to open query window, and I'm just going to do and that's all you need. And this, boom, returns this. And I've got 28 different kinds of dates in the database that go across. That was the columns that I generated. And then you've got all of the rows that I needed. And everywhere I've got a date in the database, I now have it in this nice grid, and I can use it for purposes. Either inside like a website, or in the case I'm going to show you, I use this inside of an Access database. So we're going to go there right now. And in the Access database, you can execute a stored procedure by way of a pass-through query. Now you notice here, exact same statement that I showed you in SQL Server Management Studio. And this pass-through query, all it does is this. And it's linked to SQL Server. You've got the ODBC connection, and it knows what to do. So I'm going to close this, and I'm just going to run the query. You notice the little thing here shows you that indicates it's an ODBC connected pass-through query. I'm just going to double click it like any other query. And there you go. It's the same stuff we saw. You notice how quick it was. And all of the heavy duty lifting with that dynamic SQL, everything else was done on the server. And I'm just asking for it here. Another kind of, while we're at it, a pass-through query is one where you don't call a stored procedure. You actually send through SQL that SQL Server can understand. And it might be slightly different syntax than Access, but Access doesn't care, because all it's going to do is send this to SQL Server and ask it to run it. And you can see it's a select, so it's going to return a table. So I'm going to run this against that same database we were in, and we got a table of, I think, 73 rows here that gives a period of performance for each of these projects. These are in days. I needed that in this Access database. So there's an example of a pass-through query that doesn't exist in SQL Server. Now up here we've got views, all these that begin with V are my views that I've linked in from that same database we were in. But this particular view, I could have, or query, I could have made it a view, but I only need it here. It's never going to be called by any other object inside the SQL Server database. And I thought, why litter the database with a view that's only used in Access when it's such a simple one that I can just, I designed it in SQL Server, and then I just copied the select and brought it over here and left it at that. And something I also wanted to talk about here is I mentioned linking last month, and someone in the room asked to see how I do linking of ODBC tables. And I'll run through that rather quickly. I have two tables here. They're local access tables. As you can see, they're not linked, nothing like that. They're embedded in the front end of this database. And I've got a list of databases that I can link to, and I select one, and it gives me everything I need to create a connection. And in fact, I'm lazy. If you go into design view, you'll see that the connect string is a calculated column, and I just take all the other information that is in that row and generate a connect string here. That way, when I'm using it in my code, and I use this particular method in a number of different databases. When I use it in the code, I just say, okay, go get me the connect string. I never again, now that I've written this calculated column, do I have to create a connect string to connect to this any of the databases in there. So that connect string is then used. You can see there it doesn't show you things like the user ID and the password when you hover over it, but that is how I specify the database and the connect string. And then I got a second one that is a list of all tables and views in my target database. This particular Access front end only has one SQL database as its backend. So I've got a list of all the views, all the tables, and I don't need all of them in my Access query, my Access application. So I have a checkbox as to which ones I want to link. And if I want to, for example, link it, but I want it hidden, over here. I can specify that. And then I've got some code written if I want to remove this row from the table, I can remove the row, at the same time remove the link to SQL Server. So right now we'll see that is selected. I'm not linking very many of those views and tables from the database right now, but I'm going to close this, I'm going to run it, and then I'll show you quickly the linking code. I'm not going to go through step by step, but let's go down and run. Let's see, macros, relink my ODBC tables, and you'll see a little progress meter down the lower right corner. That's how quickly locally it linked the tables. It's slower when you're going out to Azure, a little slower if you're on a network, but it's fairly efficient stuff. And then if I go down here quickly, we'll take a look at the relink code. And basically what I do is I go through and I remove all the links before I get started because I want to start fresh. So I get the list of things I want to link, I remove them, and then I start relinking them. And after I have created the table, you see I've got my connect string. That was what I was showing you as my calculated field. I create the table def, brand new. I give it the local name. Sometimes it's not the same as the source table name, and I've got an example of that in here. And the connect string, and this is a DSN-less connection, so I tell it to attach this table, link it, and save the password, so you don't have to have a DSN file or anything like that to open these tables in the future. And then particularly if a view needs an index for access to use it efficiently, I have what I call an after DDL string that will go through and apply indexes to those views that need it. And if I'll show you that. So there you are. After I've done the link, I have access, execute this, and it creates, on this particular table, it creates a unique index on the resource ID. And for access to work efficiently, sometimes you need to have them. And I'm not always sure which one's needed or not, but if access needs it, you'll get an error saying that there's no unique index or something. And that's my signal to go back into this table, set up a unique index, and rerun the links so that particular view will work. There's probably a better way of doing it, but I just wait till I get an error. And then this is something I added recently because I wasn't using any pass-through queries until recently. So what I do is I go and I find, I loop through all the query defs in the database, and if the type is DB SQL pass-through, and this is a constant inside the Access and VBA application. If it's a pass-through query, I just set its connect string to that connect string that's in the table for the database I've connected. And that's all there is to it. You don't have to, I don't remove them, because with the pass-through queries, they persist here, whereas the tables persist and views persist on the server, and I can remove those and relink them. But here I just refresh the connection string. So if I wanted to go to a different database now, I go select a different one in my database table, rerun the connection, the relink, and they'll all be done with a new connection string. We're off and running. All right. So I wanted to talk about access queries. when to use an access query and when to use a SQL view and link it in. One thing that you've probably already noticed is that when you link in a view to an Access front end, Access sees it as an ODBC table. So these are views. Here I have actual tables. These are tables, and here's our two tables that have a different name here than they do in the SQL database. And then down here, we've got tables, but Access sees them as tables. I mean, you open it and there you go, it's a table. Then you come down to queries. And my rule of thumb has been, and some people think this is overkill, but almost since day one, using SQL Server extensively with Access, I've used Azure backends, which is in the cloud. And you've got that delay, you've got a performance hit going from your local machine out to a database in the cloud. So I've done everything I can to optimize talking to Azure databases. And the first thing that I like to do is if there's a join in the query, I move it to SQL Server as a view. I try to do very few joins down at this level unless you absolutely have to. And the reason for that is as soon as you include two or more tables in an Access query, but you're talking to a SQL backend, the way that Access works is it has to download the entire results set and it does its own calculation of the join and everything right here, which means that Access has to go out, get the tables, it does the work right here and gives you a result set. Whereas if you have a view and all the joins are on the server, Access just says, oh, I want this table. And no matter how complicated the view is, all Access does is say, give me this table, and all the hard lifting, all is done out at the server level. You don't necessarily have to do this with every query, but because of my extensive use of SQL Azure, I've just made it a habit that unless it's something really simple and maybe against very small tables, I do all my joins out at the SQL Server level. Now, I do have a few in here that are just pure Access queries, but you can see I do that one, I do that one, I do that one. All of these are queries that talk to one table or one view. I'm not doing any joins in here. And you're in pretty good shape if you do a query against one table, even when you go out to SQL Azure. And therefore, I keep an eye on the selects that I do here and try to decide what I want to do, whether I want to do it here or do it out at the server. Let's see what we have here. Here you probably recognize we've got an append query. And even then, if you wanted to do an append query out at the SQL level, you would have to run a stored procedure that would give you an update and so on. So the action queries, as Access calls them, are a little bit different animal, but in this particular database, I don't have any problems with that. Now, I did want to show you a query where I do a join down here. And this is a special case, but whoops, that's the wrong one. Let's see. I've got the name written down here. Let me find it. I think this is it. There we go. Here I have a join to a local table, joined, and it's an append query, but joined out to a SQL view. The reason I do this is the local table encounters some processing and loads itself with a list of resource IDs, and I use the local table as a filter against the view, because the view out at SQL Server level doesn't know what resources it needs to return until I tell it. Now, I could do something like a pass-through query and send along a where clause and so on, but the project resources is a relatively small table, so it's, well, 350 rows. But when you filter it with the query, it comes down to a much smaller set, and it works very well here. So that's a case where if you want to use like a local table as a filter, you can join it to a SQL table or view and get your results right here. So that, with last month and this month, that's kind of the overview of the things that you do as an Access developer with your queries, your stored procedures, your views, functions, what have you, tables. That's the kinds of things that an Access developer needs to look at. What I want to show you now are some of the tools I use. And
hey, Jim?
Yes.
You have time to take some questions?
Sure, I'll do that before I start into the tools. What can I do?
One question, do you do anything ever where, let's say you have a table or one or more tables in Azure that maybe you want to persist for the life of the application instance? Do you do anything where you will bring down the content of a table and then create a local temp table or something in Access to have that data cached for you locally?
You know what I'm talking about, don't you, George? Yes, I do. And that can give you some huge performance gains. So let's go down here, this Gantt dates grid. Sure, I have a pass-through query that runs a stored procedure, but I go through some intense processing once I start running a Gantt chart here. And let me run that for you so you get a feel for what the chart looks like. So I'm doing, I'm just downloaded this from the live database, and I have copied all of it into a local table, and I'll show you that in a moment. And I'm disappointed that it's taking so long to run, but we'll see what happens here. I shouldn't have selected everyone.
So George, are you thinking about like lookup tables?
Yeah, lookup tables or, you know, significant server-side stuff that you might need that you know is not going to change for the life.
Because my thinking always was if you've got a lookup table that you reference a lot, if you pull it over at the beginning and you can reference it locally rather than calling it and calling it and calling it.
Right.
Okay, apparently I've got a bad link here, but I can quickly go to out here to show you what it's generating. Let's see. So if that had run, what you would see is this. This is, I think I've shown this to you folks before, but this is an Access report. And it's using that data that you see over there in the database. And I do run that stored procedure and load it into a local table. And because I do such intensive processing on it, the local table, it's predefined, and I've got it indexed. This is the table, well, it's empty at the moment, but it's indexed, And I use the seek method to get at everything I need in this table by using the primary key and other things. And the primary key in this case is the project ID and the date type. And I generate that from there. If I didn't have this local table, the Gantt chart would take forever to run. But the fact that I downloaded it and put a primary key on it and use the seek method, which is extremely fast in access, allows me to make this thing viable. Also, I've got some other tables, Dawn, like you mentioned, resource IDs. I just needed a list of the resource IDs and I download them so they're there. Let's see, a list of project IDs. Again, when I start up the database, I download those so they're there available to me for on-the-fly queries or other queries or what have you. So yes, George, it is very advantageous to download certain things that you use a lot instead of making multiple calls out to SQL Azure or your SQL database.
Thank you.
Other questions? Is anyone awake? Okay. Well, I'm going to start showing you some of the tools that I use on a daily basis. And I'm going to start with the access tools because you're access developers. If I waited till last, I might not get to them. So one tool that I use that works with SQL databases is Rick Fisher's Find and Replace. I suspect that some of you do use this. I've used it since the mid-90s when it came out. You'll notice this utility has only been tested with access through version 14, which I believe is 2 versions ago. Maybe Access 2013 is the last time it was tested, but it continues to work. You can't get rid of this, but it only comes up once per session. And this may be familiar to you folks. Very, very dated. The thing was designed to be used on a 640 by 480 screen, but it still works for the most part. And it's not just a find, but a find and replace. So let's say I want to look for, let's see, lookup. I want to look for this table. In fact, I'm going to rename, copy, come over here and paste, make sure I didn't misspell it. And I'm going to search everything. And I'm just going to, because of what I've selected, it's just going to generate a table of results. That quickly, I now know everywhere inside my Access database where that table is referenced. It's a table, it's referenced in 4 queries, and it's referenced in code in 1 module, but it looks like it's referenced in 2 functions. And if I come here, I double click on it, I can get in there and see where it's used. But this is a replace. So if I wanted to replace it with something else, I want to match whole word. So I'm just going to put 2 X's on the end of it. And it found a table by the name of that. So I'm going to say, yeah, change it. And then it found a query, and I'm going to say, yeah, wherever that appears in the query, change them all. So I'm saying yes to the entire document. Now I'm off in another query, and I go into code. Here we've got code, and you can also say yes to all if you're confident. The database will now work continue to work, but I've renamed something. Extremely powerful. The problem with this is it's awkward, although it's powerful. It will not make changes in macros. And I have found that as it ages, it's not finding everything that it used to. For example, if you put descriptions on your fields in your queries, sometimes it just doesn't see those. And to me, that's important because sometimes I'll put a description on a query field because I want an explanation of what that field is doing, particularly if it's a very complicated expression or something. So this does have its limitations, far more than, but it has far more capability than I showed you here. Now, just last month, a German fellow came out with a modern version of this. It's not really a rewrite of it. It's his own version of a find and replace. I haven't installed it on my Office 365 yet. I've been testing it in a virtual machine. So tonight, I'm going to show you a Northwind database. And normally you would come in, you'd see something like this. But when you install his, instead of being an add-in here, and you see I have find and replace here that I just showed you, it comes up and becomes its own tab in the menu bar, and I do a find. Much cleaner. You can look around. It's still in its infancy. I haven't found any errors, but it's a little awkward to use. But I'm going to find inventory transaction types. So I'm going to rename, copy. And to make the first one simple, I'm just going to look in the entire current database. I want to match the whole word. The accelerated search will use a cache. I don't know if the cache is accurate at the moment. So the first one I run, I'm not going to use the accelerated search. And I'm going to say, I only want to see a list of it. Although you can save the results to a database or a file, particularly if you need to then laboriously go through them one by one and examine them in an easier format than just a list. But I'm going to find all. Well, that's interesting. So the Northwind database has a table that no one uses. This would be deleted from one of my databases. But now I can do an accelerated search because I know that it's now scanned the entire database, and you can see how much faster it goes. So if you're doing multiple searches, trying to find things, always use the accelerated. This also lets you do it saves your searches. So I was looking for purchase order status a little earlier tonight when I was getting ready to show you this. And there you see that the table purchase order status right here is, there's a table that's used in one query in one form. If I wanted to change it, I do a replace here, replace with, I'll put 3 X's after it. And again, I want to match the whole word. You got to be careful. If you're doing replaces and you do something real short like purchase order and you change it to something else, purchase order status will be changed also. So you got to be careful that you match the whole word unless you really know what you're doing. Although if you've done a check before you do it, you'll kind of know what's going on. But I'll go ahead and replace all. And well, I could do a replace next, and it'll find them one by one, tell me what it is, and I could even here say, you know, in this particular instance, I want to call it something else. I'm not going to do that here, but you can edit each of the replaces as they occur. And now in the entire database, you'll see we've got purchase order status XXX, and I'm going to put them back for the moment to show you the replace all. And as you can see, all three of them were replaced and put back the way they were. So that is very powerful. You can come in here and do custom settings and save a preset. I have a setting called no tables or macros. So I can select that. And now if I'm doing a find on purchase order status, it's not going to look at macros and tables, and it'll tell me what it finds. I needed that recently. I didn't care about tables and macros. So as you can see, it didn't find the table, but it found the two other instances of it in here. And going back to the custom stuff, I mean, you can get in and do custom lists of properties. If you only want to be looking at, for example, row sources, you could clear everything and only look at row sources. And that would then give you things like your combo boxes, list boxes, anything where you have a row source defined if you just want to look at them. Very, very powerful. This was, I think I got it for $30. The price has gone up. It was on an introductory until a couple days ago, but I think it's $40 right now. Well worth it. I have not found any errors. I have found some things that make me think it's not finding everything sometimes, but I can't put my finger on it. But so far, it's done exactly what I've asked of it. So,
hey, Jim.
Yes.
Yeah, this is Dave, and I'm wondering, I imagine that the replace would not work for linked objects, but does the find work?
Oh yeah, the find should work. Unfortunately, I don't have any linked objects in here. Well, yeah, it does work. Let me open another database. I have linked access tables, but yes, if you have linked access tables, it will find and replace, just like Rick Fisher's find and replace does. So if you have a linked access table, let's say this were linked, and I wanted to change the first name field to take the space out of it, it not only would change it in the linked table in the outside database, but locally and in all the other stuff here. So yes, it does do that.
Wow. Thanks.
It will find in a SQL Server linked table, but you cannot do a replace in an ODBC linked object.
Okay, thank you.
Mm-hmm. Then other database tools I use that are access specific. I'm going to go back to my other database here. That you folks may be familiar with are the FMS products. Total Access Analyzer and Detective are the two that I use the most. And the Total Access Analyzer, it will also work with SQL databases. And I'm going to do a quick search on tables, or a quick analysis of tables. I'm going to, let's clear all. Let's pick some ODBC tables and some local tables, and then I'm going to run an analysis. I didn't try this before I got online tonight, so if it fails, but it didn't. So I just did a quick analysis of a select group of tables, and I can view that now. And you come in here, I can see what tables are in the list, any errors it found, suggestions. It's telling me that I've got a number of things here where primary key has more than one field, things like that. Primary key is not an auto number field. So this Access Analyzer will not only give you a complete picture of your database, but can help you find and fix errors, improve performance. There's a few performance things, and just the 7 or 8 tables that I analyze, it's got some performance things it's bringing up. It looks like it's mostly saying doesn't participate in a relationship, which, yeah, that doesn't matter with these SQL tables because that's often another database, but all sorts of good information you can get. And if you run a complete analysis, it'll analyze your forms, reports, modules, your code, everything. And there's over 400 different reports you can generate to help you figure out what's going on in your database. Whenever I get a database, it's brand new to me, that's pre-made. It's, you know, the most common database there is, one that someone else created. I run this against it to find out what's going on. So that is extremely valuable, the Total Access Analyzer. And then the other one I run is Total Access Detective. This will detect differences either between objects within one database, or if I run this outside of Access, I can run it to compare two databases and find the differences in two databases. And this is extremely valuable when I'm doing a lot of changes, particularly to tables, and I don't want to keep track of the changes I've made. I just make them, get my development version working, and then I run Detective to give me a list of the differences. And that way, if I've been working on a development copy, I can bring in the client's live copy, shut them down for an hour or two, and get the two databases synchronized on their schemas and give it back to them. So it's a lot easier than keeping copious notes on the changes, sometimes minor changes I've made. So I'm not going to run that now, but Total Access Detective is part of the whole FMS package of the Total Access Developer Suite, which also includes code tools and some there are, well, let's go there. We've got a little bit of time, so I'm going to open so write visual code tools. So this comes from FMS. You can do these kinds of things. You can find unused variables. There's a bunch of builders in here. For example, DateDiff Builder. So you can come in and put in all the things you want on DateDiff, and as you build it, it will change down here, and you'll see what the syntax is of what you're generating, and then you can either insert it into your file right here, copy it to the clipboard, put it in Notepad, whatever you want. A lot of builders. So if you get tired of, for example, building a record set, you can come in here and specify what you want, the table, the fields, blah, blah, blah. I mean, all sorts of stuff. And then you can, once you like what you see here, you can insert it into your code. So a lot of good stuff. There's also the Total Visual Source Book. Also over here, this is a shortcut version of some of the visual code tools. And then, I didn't even think of this till I got in here, but I also use MZ Tools. And MZ Tools, I think, is probably used by more people than the FMS tools because it's cheaper, and in some cases it runs faster. For example, right here, I've got indent lines. So if I just select everything and I indent lines, it's going to say, well, do I want to do the whole project? Do I want to do the file, or just the current method? And once I'll do it in the file. So this whole basic module, and I just ran it. There wasn't anything to do. Let's do this. This is really nice because you can configure it, and you're done working inside of a procedure, and now you want it to look nice. You just do indent lines, and boom, you'll see it indented them. I have it defined for 3 spaces for an indent. So those are some of the tools I use for Access. Now, as an Access developer going to SQL Server, I'm going to show you some pretty cool stuff. Yes.
A couple of quick things. First of all, if anybody's interested in more on MZ tools, we have a whole presentation reviewing it, and the video is on YouTube, on our YouTube channel. So if you go to YouTube and search for DAAUG, D-A-A-U-G videos, you will find it there, MZ Tools. It's actually our most popular video on our channel. Second thing is, what is the download site for the new Find and Replace?
I don't have that at my fingertips. I will try to get that at the end of the session here.
Okay, thank you.
Mm-hmm. All right. I'm an Access developer back over in SQL Server where I tend to live nowadays. That's where I generate my income. So I'm going to close this and I'm going to show you some of the tools I use here. I use some tools called that are put out there by a company called Redgate. And Redgate is like the company for SQL Server developer tools. One that you can get for free and install into your SQL Server Management Studio is SQL Search. This is kind of like the drug. The drug dealer gives you something for free. And you'll use SQL Search and you'll like it so much that you will go and purchase their complete tool set. I have the SQL Tool Belt Essentials. But anyway, so SQL Search, come in here and let me see, Prism Pog, there we are. I want to find out wherever table project is used. And I want to match whole word only because we've got some tables in here that are table project, blah, blah, blah. And it will immediately, 14 results inside this database where table project is referenced directly. It's referenced in functions, tables, procedures, and views. It's very configurable. I may say, you know, I only want to know what views reference that table. And there are 2 of them. And you come down here and you can see where it's referenced. And it looks like it's only referenced in my comments. I've actually, well, there it is. So I select the View and Object Explorer. I script the view and you go there and very quickly, there we are, table project. And if for whatever reason I need to do something, I now know where table project is referenced in this database, or at least in the views. I can set this up to scan all the databases that are connected to on the current connection if I want to do that, including the system databases. I'm not going to do all of these, it'll take forever. But so if you've got multiple copies, you might have 2 copies going because you're doing some parallel work and you need to make changes in both. You can check more than one database at a time. So I'll do that. And let's do a refresh. That was probably a bad one. Well, I'm not going to go there, but SQL Search can help you find anything you need in the database. And it not only searches what you see here, but triggers, functions, and you can even, you know, other is kind of a mishmash. I think it'll even find it in extended properties if you're looking for a string in extended properties of a table or a view. And extended properties in SQL Server, if you, for example, create diagrams in your database diagrams right there, and include a table in a database diagram, it will attach some extended properties to the table to help the diagram builder. Another thing that I use in the SQL tool belt And I need to tell you that the SQL tool belt is not cheap. It's like 8 different applications. And what you do is you purchase a perpetual license. And it's about $1,500 for a perpetual license, but you can use it forever. The thing is, both the applications and SQL Server move on with time. So for about 20% a year of the purchase price of the perpetual license, you get maintenance. And the maintenance gives you all the updates that come through, and you're allowed a certain amount of support, either email or call-in support if you're having problems. I have never used the support. These are very good. So SQL Prompt is something I've been using over the past month, and you may have noticed me doing something and you didn't know what it was. So I'm going to script the view as an alter, and what I'm going to do here is you'll notice we got brackets and so on. I just ran a formatter, and the SQL prompt, among a million other things, allows you to define custom formats for your code. And it's got a whole bunch of them defined. You can go in and let's see, SQL prompt, edit formatting styles. You can come in here. I'm using the default. I'm going to preview the current query. Maybe I prefer my stuff to be collapsed, and it'll show you using the current query or the sample what these different things look like. There's what it looks like indented, right aligned, and you can create a style, and I'll just call it custom style. And in here, you've got all of these things, and you can define how your common table expressions look. You can define your casing, reserved keywords or uppercase, whatever. You can set up how you want your parentheses to look. If we go down here to the current one, this is a bad one because it's so small. But you can set up how you want parentheses to be. Just about everything you want in the way of formatting you can do, and then you save it as your custom style, or as I'm just using the default at the moment because I kind of like the default. And every time you bring up a view, a stored procedure, a function, you can run that and you get a consistent way of looking at things. It may not be perfect, but it's always the same from view to view, object to object, and you get to the point where it's easy to read. Now, one of the cool things, and we're getting short on time a little bit, so I'm going to show this, is something I use for deployment all the time. There's a schema, compare and deploy. Now, this is similar to Total Access Detective. But Total Access Detective is only a compare. With this, you not only can compare, but if there are differences, you can deploy the differences from one database to another. So I'm going to make this database I'm using tonight the source database. Takes a moment to come up. And I'm going to take an old version of it. I went in a little earlier and made a few changes to be sure that I'm going to find some differences, and I'm going to make that the target. Now, I don't need to deploy any changes. You can just use this as a compare if you want. And you have some options if you need usernames and passwords and other things. You can do mapping. You can say, I only want to compare certain tables. If you want to speed things up, I'm not going to do that. Sorry about that. So let's come back. But lots of options on your comparison. I'm just going to do a whole database comparison here. Compare now. It's doing the comparison, and it'll present you with a list of differences. And it's saying there are 52 objects that are in both databases, but there's something different about them. There are 10 that are in the source database that don't exist in the target, and there are 3 in the target database that don't exist in the source. And right now, if I wanted to, I could generate a report. It gives you an HTML report. And you can save this report. Oh, I didn't have any selected, just a moment. You can save this report and send it to someone. Or you can just use it for your own purposes. And here, very, very interesting. You can say, okay, this V report Gantt 2 is something that it's going to be added to the target. And it shows you what's going on there. Let's find one that's modified. And what it does, it shows you what is different in the source and the target, and allows you to make some decisions about what you want to do. Now, this is a report, but also if you come in here with the 52 that are similar, you can just click on one, and down here it'll show you. It looks like what happened here is I renamed a constraint. That's the only real difference in this table. So, but if I now wanted to deploy these changes, so let's do this, and let's deploy to resource, schedule master, and schedule task. It looks like they're mostly constraint changes, but I'm going to deploy now. And I have the option of creating a deployment script that I can go in and modify, or deploy it directly from here. And I'm going to deploy it directly from here. If there's anything that's dependent on what I'm changing, you can make sure that they know what the changes were. I'm not going to deploy the dependencies on this particular one right now because it'll take a while. But then it generates a script, and this is the script that's going to run for those of you who like to look at code, and deploy. And we should see, there we are. The 3 we deployed are now, they're identical and they don't show up. In fact, the resource, there it is, that's what we deployed. They're identical now. And we have 62 differences. I can't tell you how valuable this is. If you go through and make dozens or hundreds of changes in your database, it really is this easy to do a deployment. Now, you can get yourself stuck if you do some very serious changes and convoluted stuff. You might have to do a deploy in several pieces when it starts throwing errors, but I've never been able to, I've been unable to make the deployment I need using this tool. This is a cool tool.
Hey, Jim?
Yes.
Yeah, I just wanted to say that on a project that Jim and I work on, and we have test databases and live databases, local databases, Azure databases, and both the schema to compare and deploy and the data compare and deploy in this tool are spectacular, absolutely magnificent. We can sit there and make massive changes to the next version of the application database, and I mean, Jim, like, you know, a couple of clicks and we have it, the target database totally updated. It's spectacular. Do you know if they have an evaluation version for people that maybe want to try it out?
I believe you can download the SQL tool belt, go to redgate.com, and you can evaluate it for 14 days for free.
Thank you.
Fully functional, no limitations at all, except the 14 days. I'll tell you though, you'll get hooked, and in 14 days, no matter how much you use it, you only scratch the surface. Then the other thing I wanted to show you, which George just referenced, I want to do a data compare and deploy. Again, you can do a data compare with Total Access Detective in Microsoft Access, but here you can find data changes, and in this case, I can deploy data from the source to the target if I want to synchronize data. I use this all the time to pull live data down from the live website to update my test version, so I'm testing against what amounts to live data. But there are other times where I'll, maybe in development, I will create a new lookup table and dump data into it. Once I've deployed the schema, then I can dump the data I've put into it into the live version when we deploy. So we can see here we have 38 tables where the data differs. And you can see where it's only in the source, where they're different, or it's only in the target. So it gets kind of hard to read, but you can come in, and once you learn to read it, you not only know that there are differences, but you can see what the differences are. For example, schedule name here is, they changed it to this for some reason on a schedule. So you can look at them, and then if you decide, oh no, I don't want to do that one and I don't want to do those, you can do a selective deploy if you want. Or if you only want to do one table, there is a way to select and deselect everything. But you only want to do one table, maybe the user log, you can do that. So I'm going to go ahead and run the deploy here. You can see we've got, well, 335,000 differences. I'm not going to do that one. Now we have 14,000 differences. Because what this deploy does is it generates a single line for each difference. So in the script, script's going to have 9,600 lines of an update. And it's telling me that, you've got primary key or unique indexes and so on, and foreign keys. So are you really sure you want to do this? Because if you don't know what you're doing, you might collide with foreign keys and unique stuff. Generally, it's not a problem. So I'll click deploy now, and we'll probably have a problem tonight. But these are all warnings, not errors. All right. Table project, okay. So we did have an error, so we come back and do this. Let's just not do table project. If we get an error on this one, I'll just pick one table and show you how it works. Okay. Let's see, actions, exclude all, and we'll just do this table. So we have 38 differences. Let's see if we can get this one to work. You can see here, there we go. So what it did is the user log is no longer, excuse me, the table we just did is no longer here under differences, and it's under identical. But in a more controlled environment, because these two databases I've pounded on hard over the last 2 months without really keeping track of stuff. In a more organized environment, you can upload, download, synchronize your data with this tool. And 90% of the time, 95% of the time, you don't see the errors I showed you just now. But it's wonderful stuff. Another thing that comes along with SQL Prompt is in SSMS, you get a little app called Tab History. And everything you do with these tabs, whether you save them out to files or whether you just kill it. See, I said, no, don't save SQL Query 17. But if I go into Tab History and I look at all tabs, there it is. And this is wonderful. If you're doing all sorts of screwy stuff during the day and you get rid of a tab and then, oh, I needed that select statement or whatever. You come in here, you just click it, and boom, it opens it up in a query window in the current active database, and you can continue working on it from there. You can also, with tab history, I've decided, you know, I need this for a number of days or weeks. I can put it on the starred list, and then when I close this, go into tab history, several days ago, what was it? And I can see these are the ones that I kept, make them easy to find. So like I've got a mass update to a database here. It just brings it back, it's ready to go. Wonderful stuff. It's hard to describe how useful this is because I had always save these off to SQL files, and then when I needed it again, I go back and get it. And now all I do is put it in tab history, and it's almost unlimited. I can define the amount of space I want it to take, you know, 5 megabytes, 20 megabytes, and it'll store as much stuff as the amount of space that I allocate it. And I don't have to think about saving these things in case I want it again tomorrow or next week. Let's see. Seems to me, one other thing. When you're looking for utilities and you want to roll your own, I'll do this quickly. We've only got 4 minutes. I have my own area called T-SQL, and I've created a whole bunch of stuff in here. I've saved off a lot of my functions, my views as SQL files, but I've got something I call my admin utility scripts. And this is a lot of stuff that I have pulled off of the internet, maybe run the SQL prompt formatter against it, maybe tweaked it slightly, or maybe just use it as it is. But for example, I needed recently to know all the date fields in the database. So I go out there, I get it, it's right here, I just execute it, and boom, here you are, the table, the column, and the type. As you recall from last month, there are several date types, and I found this code by looking out on the internet. I just said T-SQL list all date fields, and I found, you know, half a dozen ways to do it. And so you get out there, and when I find something, I don't just bring it in and run it. Even if I don't know if I'm going to use it again, I immediately save it off to my admin utility scripts, give it a descriptive name, and there you go. It's there for me to use in the future. I've got for primary keys, I've got foreign keys without indexes, all sorts of things I've looked for that I found out on the internet. All right, it's 2 minutes to the end. So that is my synopsis of SQL Server for Access developers spread across 2 months. And I could keep talking and talking and talking, but that's it. So thank you, folks.
Thank you. Any final questions?
No, but thanks for showing us all
Yeah.
that, Jim.
Yeah. Thank you, Jim.
Excellent.
Yes, very nice.
I hope that I showed some of you some things you didn't know about. As you can tell, I'm just enthusiastic about database development, and
Right.
I'm glad I can share it with you. So thank you again. Good night, folks.
Good night. Thank you.
Thank you.